All right. We'll quickly talk about work and power. Isn't that a soothing background, Quinn? Doesn't it sort of make
Because
you
it's
want to?
blue.
Yeah.
I want to sit on a beach looking at it.
Yeah.
Or like standing on a little raft.
Makes me feel like I'm flying through space. I'm flying above the ocean.
Just dehydrating.
And a helicopter takes off water.
Yeah. Okay. So power. Power again refers to the rate of doing work. How fast do you do the work? How fast do you do the work? You could also define it as the rate at which energy is transferred from one object to another. The rate at which energy is transferred from one object to another. I think the white font really stands out well too against that background. What do you say? Easy to read. It's making me feel very powerful.
Or sleepy.
Got blown over, so they put it all on the back up. And then a tree hit that one. So they had to fix both.
You could say that power refers to the amount of work done per unit of time.
It's a bouncy thing.
That's just the keyboard trying to come up. Mathematically,
Yeah.
power equals work over time. Pretty straightforward. Power is work over time. Work, of course, measured in joules. Time, of course, measured in seconds. So the unit of power is the joule per second. Joules per second. Now, there's a special name for joules per second. Yeah. Given that power is work over time, joules per second, which we refer to as a watt. 1 joule per second is a watt. Named after?
Christopher Watts
Not Christopher Watts, no.
is an educated guess.
Well, I could make a comment about Chris's ability to do work and how we would define the watt if it was based on him, but I won't.
0.5 watt.
I'll leave that for you guys to define. So, quick sample question here. How much power does a 50-kilogram girl develop or require? How much power does a 50-kilogram girl need while running up a 2-meter high flight of stairs in 0.75 seconds? Golly, that sounds an awful lot like the Personal Power Lab, Quinn.
Oh, that's
She does work against the pull of gravity, right? So she has to come up with enough force to push her 50 kilograms up the 2-meter high flight of stairs in 0.75 seconds. How many watts of power does she need? Does she have enough horsepower to do it? Okay, so we're going to do power equals work over time. We've got to figure out how much work first. Work is going to be against the pull of gravity. It's going to be mass times gravity. I could probably do it all in one big giant step, right? I couldn't do the nice background with the formulas, so I had to switch to that one. It's not near as soothing.
This was like
work over
inside of a whale.
Are you speaking from experience, Quinn?
Yeah.
What was the time again? 1.
Polio.
Pinocchio.
Oh.
Was the time
You said
1.75?
Yeah. There's a lot of
0.75 seconds, yeah. So FWDT, right? So we got our work done is going to be mgd over t. 50 kilograms, 9.8, distance is 2 meters, 0.75.
I think I might have screwed up. I got
Oh, I disagree.
1,300.
1,306 watts, or we might even say 1.3 kilowatts. Of course,
Is it
1,000 watts per kilowatt, right?
Okay, I'm gonna write that down.
Right? Come on, kilowatt.
1,000 kilo.
Kilowatts. Your standard light bulb, your 75 watt light bulb, gives off 75 joules of heat and light per second. Only about maybe 10 or 15 joules of actual light. Most of it is heat. That's really all there is to it. There's nothing too challenging there. Oh, 1 kilowatt, of course, is 1,000 watts. Is there another one here? Oh yeah, the textbook, if you're doing questions in the textbook treats things a little bit different. They like to do this. It's kind of neat, actually. Power equals work over time. Power equals F times D over time. And because D over T is equal to velocity, then I can take that D over T here,
You just put V,
put it in there, and what are you going to get, Jory?
that's V.
FV, exactly. Power equals, go away. Power equals force times velocity. That's what the textbook likes to use. Okay, so you might want to just have that one at your disposal as well. This means you can now look at, there's a few questions there on page 331 and 332, numbers 1, 2, and 3. You should have 2 handouts on work that include power as well, that you are probably working on. I believe someone a few years back said that that previous background here, this one here, oh, I gotta go a long ways back.
The ocean?
They thought that the ocean one, they, for whatever reason, this reminded them of
Castaways?
Super Grover.
What's that?
You don't know who Super Grover is?
No.
Oh, you guys. And so they wanted me to tell you that today's notes, or today's lesson, has been brought to you by the letter P. Super Grover. I don't even remember who it was. It's been so long.
I remember you got cartoons as a kid.
No? Grover's not a cartoon.
Muppet.
He's a Muppet.
Muppet.
Yeah, he's a Muppet.